Hello and welcome to our webinar on revolutionizing industrial energy use with high-temperature heat pumps. My name is Frederick Matheson. I'm joined here in the studio by my colleague at Aneo Industry, Michael Banta. Michael is an expert in high-temperature heat pumps and steam-producing technologies and has been active in the industry for more than a decade. And he played a crucial role in developing innovative heat pump systems during his time at Syntef Energy Research. We're also joined remotely today from Cordin Apargaus, who is the Senior Research Engineer at the Eastern Switzerland University of Applied Sciences, and he's at the Institute for Energy Systems in Buch. Cordin is an internationally recognized expert of high-temperature heat pumps and has literally written the book on the topic. We're also joined by Dan Stefanica, who is the head of EU projects at the European Heat Pump Association. With a total of over 12 years in project management and 5 years managing projects of EHPA, he's overseen more than 30 EU-funded projects totaling more than 85 million euros, covering all aspects of the heat pump value chain and all the associated non-technological aspects. Dan, would you like to begin?
Yes. I will do my best to share my screen. We do heat pumps, as our name suggests. We've been founded in 2000, and we have many members from all over Europe, representing 30 countries currently. This is our structure. I just put it here because for the purpose of our discussion today, I would like to raise your awareness that we have many working groups, task forces, and committees. But for this particular topic, we have the Industrial and Commercial Heat Pump Working Group, which is specifically designed for these type of heat pumps. And we also have the Research and Innovation Committee that I chair, which basically deals with many of the topics that Cordin will present later, but mainly research and innovation and cutting edge research. So a little bit about what's happening in Europe, as I come from the project side, and a little bit of policy, because that's what we do at the EHPA. And again, Cordin wrote the book on high temperature heat pumps. But heat pumps in Europe represent many quality, high-paying jobs, and represent manufacturing in Europe. The annual sales of heat pumps, you can see on the screen. These are the air-to-air, air-to-water, and so on. As you can see, there is a small decrease in the number that were sold in 2023. I'm just going to go very fast through these slides. What I wanted to show to you is, although the domestic heat pump market may have been readjusting by 5%, the industrial heat pumps are on the rise. Just a little bit about the research going on at EHPA, and you'll see why I talk about this later. At EHPA, we have many projects, everything to do with heat pumps, training, one-stop shops, liaising with policymakers, policy in general, liaising with municipalities, high-temperature heat pumps, storage, and so on. But what I wanted to show to you is, of course, that we have projects with high temperature heat pumps, specifically Spirit, push to heat, and Betted. Betted is about the dairy industry. Spirit is about high temperature. Push to heat is also about the paper industry, and I think sugar as well. So everything that basically you can use in your daily life could and probably lately is being influenced by high temperature heat pumps. And because I'm pretty sure you'll share the slides afterwards with the participants, you have here a breakdown of the projects I have just mentioned. So push to heat with its demonstration sites on the paper industry, Q-Pinch R&D plant in Belgium, paper industry in Italy. Then about Spirit, another project, prawn processing, sugar production, paper production in Czechia. Then Betted, that has just started. And again, it's about heat pumps in the dairy industry, including high temperature heat pumps. Again, because I work in projects, so we talk about the funding calls. Hopefully, you know about this. There is, in a few days' time, with a deadline of the 19th of September, there was this Life 2024 CET heat pumps supporting the roll-up of high-quality heat pump installation scope A and B. Now, scope A and B means that there are two parts to this call. One of them is about skills and new business models, but the other one was about helping European industry by liaising with heat pump manufacturers, so basically including heat pumps in the industrial processes. This is based on our cooperation with CEPI. CEPI is the association here of paper and pulp. And I would say that the funding agencies really appreciate and want to encourage the development of high temperature heat pumps. They do this through this call, but I'm pretty sure that this type of funding calls will continue, especially with the New Horizon work program. Just in case you want to participate in this, just in case you want to know more about other associations that participate in this, other stakeholders in general, at EHP we have a one-stop shop where you can find everything that you need to know about future calls. And if you have a good idea or something that you think is fundable, feel free to get in touch with us. We will make sure that that your ideas are presented to the decision makers and ultimately to the funding agencies. A little bit about policy, because I'd be remiss if I didn't present this by my other colleagues. Basically, as you remember, there was a lot of interest, a lot of importance given to heat pumps in 2022. But lately, as the situation has a bit adjusted, our heat pump action plan has been postponed. One of the things that the heat pump action plan had, the heat pump action plan in a nutshell, was basically how do we achieve the very ambitious policy goals. And EHP had a plan, and we presented it to the Commission, and the Commission wanted this plan to become official. Unfortunately, because of the geopolitical situation, as well as the Commission switching, basically there's a new Commission in place, or there soon will be, this has been postponed. One of the major points that we had on this policy ask was to unlock the potential of large heat pumps, and we thought that this was so important that we put it in the 5 points. That's all from me. I look forward to the questions. Thank you.
Thank you, Dan. One quick question, just out of the top of my head when I saw your slides, basically. So you talked a lot about projects, and the question is, on what kind of technological readiness level are these? Are these development projects, research projects, or really huge, larger industrial scale projects?
They're towards the larger industrial scale projects. So a TRL of more than 6, with 9 being the goal. And what I forgot was also that the Innovation Fund, for example, funds these type of projects. So that's also something to look out for. Again, any funding question, feel free to ask us. Yes. We will assist you in this.
So TL9 basically means systems will be completely finished and thousands of them sold. How far away are we from TRL9? And if you reach TRL9, is your work then basically finished?
Well, our work is never finished, of course, because otherwise I would have to look for another job. But really, the gist of it is that our collaboration with CEPI has highlighted the need for basically standardizing the processes that exist in industry. So there are some big market players that have about, let's say, 160 production sites. These 160 production sites can be standardized into about 11 to 12 processes. Then these market players talk to the heat pump manufacturers, and from our experience in CEPI, okay, this will take sometime between 6 and 12 months, but then they come up with standardized solutions for these particular processes. And then the standardized solutions being made, this means that the heat pumps can be produced faster, more efficiently, and they're no longer bespoke. So I would say, we've been doing this with CEPI for the last 2 years. The Commission really likes it. That's why they made this proposal. I would say we are about 5 years away. We're also starting a business platform at EHPA where we gather such market players and we put them in contact with the people that are actually building the heat pumps. So I would say we're at the beginning, but progress is being done rapidly because the market demands it.
Yes, thank you. Yeah, I also heard once that Norway is basically the European championship when it comes to heat pumps, basically about how many heat pumps per inhabitants we have. Is that still true?
The Nordic countries are always on top per population as a percentage, which is actually very, very good because we often get questions that heat pumps don't work in cold climates. So that is a bit of a misunderstanding if the biggest markets are actually in the Nordics. I would say yes, you're still on top. You're still on top on many of the energy transitions, and please continue. We like to give you as an example.
Do you know what we do right or better than the others?
Well, you have had heat pumps introduced for a long time, so there's no more mystery. Many countries are in the stage that there needs to be communication campaigns to let people know what a heat pump is and what advantages they have. For you, because you've been doing this for a long time, the advantages are understood. It's also, of course, that other countries have a lower purchasing power, so for them it's more difficult to get the heat pumps. And it's also, of course, the population density of Norway and in the Nordics that make it more feasible to have your own heat pump rather than being connected to a network.
Okay. There's also an important thing about people being used to having these types of systems available, because typically people will ask someone, what do you think about it? What would you recommend? And it's only 10 years ago that my electrician would suggest that we should also have electric heating in addition to air to liquid heating and underfloor, because on really cold days it wouldn't be good enough. And that's a myth, but it was a really powerful myth which has now happily disappeared. So I think this idea of having it as something you're used to is really important. And I think this also goes for when we do it in industry. There needs to be someone to say, yes, I have experience with this, I've seen this, and I know that it works, as opposed to, no, this feels like a new research project. But I'm curious, Dan, are there any ways to influence what kinds of calls that are put out for research and funding? If we see that there are questions in industry about adoption that need those kinds of research projects, how can we give that kind of input to the funders?
Yeah, so part of my job is actually, or part of the EHPA's job, is that we bring together the market players, so heat pump manufacturers, component manufacturers, and so on. And we ask them, what do they want? What do they need to be researched? Afterwards, we communicate this information in an objective manner to the funding agencies, and it is up to them to make the particular calls. As you can imagine, for them it's much easier to ask us that we have the access to all the market, and like this they have a single point of contact. The call I was showing you, the one about industrial heat pumps, and both scopes were because our members and industry in general, so you don't have to be a member to actually tell us what you need to be funded, you just have to be in the industry. They told us that this is what needs to be funded, and we, very much with the help of our members and the funding agencies, have made this possible. Of course, just having the call also means that you have to apply for the call, by the way. and these calls are quite competitive. So this is also an area where we can support you. But again, to come back to your question, if you have a good idea and you think it should be funded, please let us know, and rest assured that we will communicate it to the funding agencies, and then it is up to them to put it in the next work programs.
Very good, thank you. I think we're going to head on down to Switzerland and hear from Cordin.
Okay, yeah, so welcome from Switzerland. I'm Cordin. I'm working at the Institute of Energy Systems at the Eastern Switzerland University of Applied Science. And I'm happy to get this invitation from Michael from the company Aneo to talk about potential of steam generating heat pumps for electrification and decarbonization of the industry. So this is not a work from me alone, but we have a whole group at our institute that is working on high temperature heat pumps every day. So we just made a webinar in March this year on steam generating heat pumps, and you can imagine there were many participants, over 540 from 42 countries. These were researchers, engineers, but also salespeople, and this shows the high potential of this technology for industrial applications. By the way, these presentations are all online, so the recordings and also the PDFs of these presentations. So if you get the presentation here, you have the links. From this webinar, we asked some questions also to identify potentials. And the first question was, do you have experience in steam generating heat pumps? And mainly the participants said, not yet. So this is something new. But do you see potential? And then most say yes. So it's a lot of interest, but still at the early beginning of development. The refrigerant is an important component in this steam generating heat pumps. And here we see really a trend towards natural refrigerants with water, ammonia, CO2, hydrocarbons, or noble gas with helium, and a little also on synthetic refrigerants, which have very low global warming potential. From the heating capacity point of view, most of the heat pumps needed are between, let's say, 500 kilowatts heating capacity up to 5 megawatt, but also some in the larger scale going closer to 10 megawatt. So from the industrial heat demand, we see from studies that this starts from about 100 to 120 degree up to 200 degree process heat. This is the share of the process heat that can be accessed by heat pump technology. And there are estimates that this will have a potential of several thousand units of probably 3 megawatt size in Europe. And the major markets are the food, paper, and chemical sectors. And there is also enough waste heat available, which would be used as a heat source. When we look at US, in the United States, there are also cumulative curves of process heat demand. And you see here also up to 200 degree process heat. There is almost 70 or more % of the whole process heat demand. So this is a target share of the process heat. We can also distinguish this a little bit more in detail in temperature levels. And when we look at 80 to 200 degrees, this would give probably 30 or more % of the process heat demand for which is accessible by heat pump, steam generating heat pump technology. Here from some further details on the sectors is a repetition, but it shows again food, tobacco, paper, pulp, non-metallic minerals, chemical, and also the iron and steel industry for these temperature ranges. When we look at the research status, I'm from a university of applied science. We also see a trend towards more and more publications, and this is quite worldwide. Leading are Europe, but also China, for example, is very much developing heat pumps in their provinces. But there is a lack of compressors, and that's a main message. So steam compressors in a rather small to medium size range are quite rare. There are very large steam compressors available from older times from many companies, but reducing the capacity to a 1 megawatt, let's say, size, there's still a development need. I made a review on heat pump suppliers and manufacturers, and here is the overview from 2018, so 6 years ago. This shows different heat pump products as a function of the supply temperature that these heat pumps could achieve, and also as a function of heating capacity. The colors are the compressor types, and we saw already then that there are several heat pump manufacturers providing these heat pumps with supply temperatures over 90 degrees up to 160 degrees. Now, 6 years later, this market has developed quite a lot. Now there are more than 50 heat pump products that provide heat over 100 degrees. So the 90 degree is even not shown here on this list. So this shows the evolution of this market, and is a non-exhaustive list. For example, the Chinese products are not shown. When you look at the efficiency, this is the major advantage of a heat pump technology. The efficiency, the COP, which is the ratio between the achieved or the produced heat divided by the electricity that is needed to run the compressors, this can go up to, let's say, 4 or 5, but it depends on the temperature lift. The temperature lift between the heat source and the heat sink. And this is thermodynamics, which we cannot change. So Carnot efficiency or Lorentz efficiency are deciding or are determining the efficiency of a heat pump. And nowadays we have such COP values from different heat pump manufacturers. So this fit curve here could be used as a first estimation of an achievable COP, which is then used later for techno-economic studies to estimate, let's say, the energy savings and also the CO2 emissions reductions compared to, let's say, today's fossil-fueled heating technologies like gas boilers, oil boilers, and so on. We had a survey that in the whole value chain that was done some years ago, and the question was to find, let's say, the challenges for heat pump technology adoption into the market. And one major area is knowledge and information. So there is still a lack of knowledge among different stakeholders in the value chain, so that these heat pumps are in principle available as a technology. But product acceptance is a major hurdle, and also knowledge between planners, engineers, and so on. Then the cost view, so the economic point. Here we have challenges from the market, and these are low gas prices, low fuel prices, which will hinder electrification technology. So the price ratio is a very important parameter to push electrical driven heat pumps. And this is something we cannot change from the research point of view. It's really a market influence. Then we have the technology and the processes. So still there are research activities to increase, for example, the temperature levels of these heat pumps. This means the components of the heat pumps need to be adapted to higher temperature resistance, then reliability, to show that this technology runs and is reliable over many operating hours, and so on. We also do work on efficiency improvement by better and, let's say, optimized heat pump cycle designs, and so on. But the economic factor, like the price ratio between gas or electricity to gas, is a major driver for the heat pumps. And here we have an overview of the price ratios in different European countries. And if the price ratio is low, like in the Scandinavian countries, like Sweden, Finland, and so on, the chance or the attractiveness of heat pumps is higher. And we can do a comparison of the OPEX, operating costs parity, between electrical driven heat pump and a gas boiler. And then here we see that we would move on such a curve. So that means the COP determines the temperature ratio determines the COP, and the price ratio determines the economic temperature lift. And we see that temperature lifts between, let's say, 40 to 50, 60 degree achieve a COP of 2 to 3, and this is an average in Europe. So the goal should be to push this towards left. So as a summary, I show you shortly an overview of heat pump products, and that there is development ongoing, also in large-scale steam-generating heat pumps. There is decarbonization potential, especially up to 200-degree process heat. This is the share that heat pump technology can achieve in a sufficient efficiency using waste heat as a heat source. The main sectors for the decarbonization is food and beverage, chemical, pulp and paper industries. Here we have a lot of demand of low pressure steam up to 6 bar absolute, which is 160 degree. If higher pressure is needed, then mechanical vapor recompression would be the technology to recompress the steam to higher levels. Research activities are ongoing, especially in compressor technology for the small and medium scale. Here we have developments with oil-free compressors, high-speed turbos, and multi-stage compressors. One barrier is running systems for demonstrating this technology. If that would be increased, and it is ongoing every day, this would give confidence in this technology and would further push the adoption of heat pumps in the market. The price ratios or the energy prices are a major parameter from the market for the investment of this technology. So I'd like to acknowledge also these projects here. Push to Heat was mentioned by Dan, the European funded project. But in Switzerland, where I come from, we have also projects which are working with heat pumps like Sweet Decarb CH or Annex 58 for the high temperature heat pumps, or a project particularly on steam generating heat pumps. Here we have a list of literature from our institute that you may access later on maybe. And so thank you for your attention. That was my short intro into that topic on the potential. Thanks.
Yes, thank you, Cordin. Out of the top of my head, you were now going in depth a little bit more into the steam producing heat pumps. What is the basic difference between a steam producing and a high temperature heat pump? How would you?
That's a good question. The steam generating heat pump is really producing steam as the final medium. A high temperature heat pump is more, let's say, a general term for an industrial heat pump that generates process heat, but it could also be pressurized hot water, or it could be hot air. So it's a relative term, this high temperature. What is high temperature? There's also a question. For some 80 degree is high, for others 200 degree. I would say 100 degree is interesting, because then steam can be generated, water can be evaporated at 100 degree in atmospheric pressure.
And Did you also analyze basically how many processes are requiring steam versus hot water for as energy source? Or do you have a gut feeling how much it would be this ratio?
Yeah, it's not so easy to have this overview. I would say most industrial companies in this chemical and paper sectors use steam, but the food industry is going towards more and more, let's say, pressurized hot water systems that not particularly use steam. Today, they use steam of the gas boilers and so on, and expand the pressure down and have then heat exchange to the process streams. So steam, water, heat exchangers. Yeah, it's difficult to say, but I would imagine that most process heat higher than 100 degrees is in form of steam nowadays, and a little more in lower temperature for high pressure water. But the steam is major part. But it's a good point. They should do some further research on this potential. If you have good data, that would be useful as well.
So in your presentation, you went through some of the barriers to adoption in high temperature heat pumps, steam or not. And one of the interesting points for me was the lack of knowledge among those who are working on planning these kinds of systems, because you have a high operational expenditure was a barrier for some, and a high capex was a barrier for some. But is it possible to find ways to bring more information to those doing the planning of the installations where they'll be used? Because these systems will last years and years. Yes. So decisions we make now on how to outfit factories will have impacts for decades to come. How do we get information to the planners?
Yes, that's a very good point. And as a university employee, it's our task or our duty to teach the students how to design heat pumps and how to integrate them into the industrial processes. So I can imagine that the universities and schools develop these courses for the planners and engineers to learn these activities. So this is a major task to define in the education, to educate the planners and engineers.
Because this is what we see in any technology adoption question, is that it's always difficult to bring a new technology, even if it is many years old, into the market, because it has to integrate with so many other processes. There needs to be people who can service it. There needs to be people who understand how to put it into their models and get it to work. So I think that's an incredibly important part. But then there seems to be a point at which the floodgates open, so to speak, and people understand that, yes, this works. So Dan, I'm curious, do you think we are approaching those floodgates now? We saw in your presentation a lot of examples of these things being used, and in Cordin's presentation, huge examples of growth in the sector. Are we moving in the right direction?
We are undoubtedly moving in the right direction. Are we close to the point that you're mentioning? And people have many names for it. I still think, we talked about projects, right? So EU-funded projects. And when I look at the work program, and Cordin knows as well, so what the calls are about, for me, it seems like the future, right? So these are made a few years in advance, and it seems like the future. So if we have the projects now, and they will end in somewhere around 2026 for push-to-heat spirit and so on, then they would prove the technology. Then there are also other projects with even higher temperatures than spirit and push-to-heat. So I would say around 2026, 2028, something like that, for industrial heat pumps. Then they would start to really pick up. Again, we are dealing here with cutting-edge research, and I see many proposals for projects. And there are also, I think, and Cordin might agree that there are still many competing technologies on how to get the high temperature needed. So I think although each of the technology is bespoke to one particular process, I think there's still competition between them on also which ones will be the most efficient to standardize upon.
I also would like to, just on a general comment, I see quite often that in my experience that when you talk about steam producing or high temperature heat pumps, they are still basically benchmarked against a fossil fuel solution, which is seems a little bit unfair because we develop most of the activities are done under the premises we want to use this technology for decarbonization. So by comparison then to fossil fuels and saying, yeah, but this is more expensive and so on, this is a little bit unfair. And I think that's also why it's still so important to get subsidies somehow to get this first mover projects running. But in a decarbonized future, right, you should be, it seems a bit unfair to benchmark heat pumps against a gas boiler, to be honest. And then, of course, the economics are very important and depending on the electricity prices and how much COP you can achieve. And this is, I think, one of the main reasons why we, in a way, still need somehow some early movers, which are also maybe funded by state subsidies, Brussels or in Enova here in Norway.
Well, if you think about the communications technologies we're using right now, that essentially evolved out of the Second World War and the Cold War. So there was a huge subsidy into building these kinds of technologies. And that's also a big question in the market then, because Cordin, you were talking a lot about how it really is up to the market what kind of adoption we will eventually have of these technologies. But then, of course, the market comes down also to questions of how much we pay for emissions. So really a question to both of you. Are there some mechanisms in place or being developed now that will more accurately allow high temperature heat pumps to prove their value? Because right now, if you are emitting CO2 without any cost, the calculation will look one way. But if you have to actually pay for your emissions, then the whole spreadsheet looks different. Are there any movements in that area that will affect the industry soon, do you think?
Yes, we see that CO2 tax is a good system to regulate or to steer this decarbonization towards net zero. We see it in the residential sector, for example. In the industrial sector, the larger companies sometimes don't need to pay this CO2 tax if they can show that they do some other efficiency measures in their industrial side. So this is one way to the one parameter to steer this decarbonization. But I think the major driver or the major motivation comes from regulation, and by doing this decarbonization roadmaps, which are so the net zero goals are the major, let's say, drivers towards electrification. And you are right. So the electrification, there are different technologies, and we should focus on renewable electricity. And the trend is towards reducing this CO2 emission factors, which goes all in line using heat pump technology.
I would add to what Michael said.
Yes.
So for some projects, for example, under the Innovation Fund, you also have to calculate the CO2 emissions that were saved. So then fossil fuels or any system that has fossil fuels would not be competitive in such a submission or such technologies. And then just to add, the one of the issues we have, and we strongly advocate towards making taxes more viable. So there's a lot of taxation on electricity and not a lot of taxation on fossil fuel, or the taxation means that sometimes fossil fuel is actually cheaper. To give you an example, in Italy, in the taxation for electricity, there's also the broadcasting, because you touched upon broadcasting. So there's a taxation for having a TV or radio in the electricity, whilst of course it's not in the fossil fuels. So there's an artificial lack of competitiveness because fossil fuels are not taxed equitably, let alone more than electricity. So this is something for sure that we're working on and needs attention. And it's different from country to country, but most of the countries are in the camp of fossil fuels are less taxed.
I also think it's maybe an important point that when we look into a decarbonized future, right, we have to see that heat pumps are maybe the only technology that actually could make a cheaper OPEX or a cheaper energy price than it is today, even compared to fossil fuels and so on. While a lot of other, this is now a hypothesis, a lot of other decarbonization technologies would make it actually more expensive to run the same process on, for example, hydrogen. Would you agree, or am I completely wrong with the statement, Dan or Cordin?
I think Cordin showed very objectively that most of the processes at around 200 degrees can be made with heat pumps. So what is after that might be hydrogen, but for the moment, I think that is not the case. So
one additional advantage, of course, also with high temperature heat pumps is they do run with electricity at some level. And if you wanted to replace that and say, oh, let's make an electric boiler instead, you would have, one, the electricity cost, but you would also have incredible costs for upgrading the grid to where you were. And this is something that was just pointed out in the EU's new report on European competitiveness, that the availability of grid capacity is insufficient pretty much all over the world, but especially in areas if everyone is switching to something other than fossil fuels and wanted to go to electricity, that would be very, very difficult. So this is also a very practical advantage with high temperature heat pumps, that you don't have to expand your grid capacity in that same way.
That's completely true. I think the project which I'm presenting later on is actually substituting an electric boiler, 5 megawatt boiler there. And the motivation there was really to reduce grid capacity, to also do other things in the factory with available electricity, right? So in the future, and I think we see that already in Norway, which might be one of the countries with the highest and best electrification infrastructure, we already see now that there is not enough cable in the ground basically, and not enough electricity available to do all these electrification measures. Especially when we think that there are also like coming new technology or new industrial sectors like battery factories which should be electrified, and or data center which should be electrified. And so this is also an aspect that surely will influence the potential and the development on steam producing heat pumps and high temperature heat pumps.
So one advantage I'm curious about is predictability, because we've seen in the past few years wild fluctuations of energy prices where they've really gone high and they've come crashing down again and been difficult to predict. Are there any advantages that some of the high temperature heat pumps users or some of the research projects that you've been involved in see in simply having a more predictable energy cost by installing this approach?
Yeah, the advantage of a heat pump is that it's using electricity, and the availability of the electricity is time dependent, and also the costs. And so it's possible to run the heat pump at times where the electricity is cheap. And that this is another flexibility that this is possible with these heat pumps. So we need to think in a sector coupling way.
I would add the strategic autonomy that electricity gives us, because it can be generated here, right? So most of the fluctuations that happened in the last years were due to geopolitics that were outside of the European Union's control and outside of its borders as well. So we should, now the prices have gone down, yes, and this has fossil fuels, and this has caused a shift in the policymakers' mindset. That's why I would assume that the heat pump action plan was also postponed. But we should not trade dependency on a country outside of the European Union for dependency on other countries outside of the European Union. So this is something also that even if the prices were the same, electricity produced here provides the strategic autonomy and independence that it's worth something to have, and it for sure would cut cut the fluctuations off quite a lot.
Good. Okay. So just a few follow-up questions before we forget this. One for you, Cordin. Do you see any options now in growth for natural refrigerants in the heat pump developments?
Mm-hmm. Yes, that's definitely a trend. We see it in interviews, we see it from surveys, we see it from feedbacks from webinars that there is a trend towards natural refrigerants. But it always needs to be checked if a natural refrigerant could be integrated in a certain site. For example, the hydrocarbons, which are flammable, cannot always be implemented in a machine room. Maybe they will be more installed outside in a outside the building. Ammonia has a toxicity, which means we know how to run refrigeration systems based on ammonia, so it's a standard technology. But if more and more will come in the heat pumps, the installers and so on need to be trained how to handle that. And if we go to synthetic refrigerants, we have the risk of the environmental aspects. So this could produce some harmful acids if they would leak out of the heat pumps. So there are some considerations which are not, which are discussed. And I see in Europe mainly the trend towards natural refrigerants, and other regions from the world will follow. I was in China just last week, and here we see mainly synthetic refrigerants. Japan has also categorized HFO refrigerants as somehow natural or special category. In the US, here also synthetic refrigerants are still a major part of the refrigerant amount. So it's a question of these environmental questions about the strategies. But as a university employee, or I would really go to natural refrigerants where it can be used. So that's my point of view.
I would like to add, for me, it was always water is maybe the most natural refrigerant. We even can drink it. And of course, when we can apply in steam generating heat pumps as early as possible and the temperature lift, steam or water as refrigerant and compress it up and deliver it to the process, that might solve a lot of issues when it comes to environmental aspects, toxicity, but also how to build the system. So in our experience at Aneo Industry, we have now, we start with water as refrigerant at a temperature already at 80 degrees. And for the really large projects, we actually could think of using water also down to 40 degrees and from there. So for me, I always try to get acceptance and do it with water. But of course, water is also, it's as a refrigerant is a bit more challenging when it comes to overheating and so on, but technical details. But that can be solved, I guess, by compressor development. But my message would be, let's also focus on water as a refrigerant more often, because it somehow is in a lot of investigations forgotten.
And water is never going to be an environmental problem in that way.
Wouldn't say so, yeah, but...
I have a question for Cordin. Concretely, when you work on research into high temperature heat pumps, steam pumps, and so on, what are the very typical research activities? Is it building, prototyping, modeling? And what kind of experiments are typical in the development work that's being done now?
Yeah, as a researcher, we research on the different components of the heat pump. So the heat pump consists of heat exchangers, evaporator, condenser, but then the compressor, then expansion, cycle design. So these are all, let's say, factors which influence the efficiency of the heat pump. So we are very much researching efficiency improvements. Also, the refrigerant is a possible parameter to adjust to improve the efficiency. You can imagine, for example, refrigerant mixtures, which would even be better than a pure refrigerant for certain applications. For example, when there is a heating up streams for air heating, for example, or hot water generation. And then there is the scale, so the scale up. So typically we have small scale units in the lab, and then scaling it up to pilot and demonstration projects. Then we have some kind of consulting or knowledge transfer activities to really inform the planners, engineers, educate them. So this is also related to the research part. And then there are more and more topics. I think our work is not finished at all. So the whole heat pump trend is reflected in the research activities as well, together with the manufacturers, with the installers. This goes hand in hand. We also are working on European projects. So this means it's a very networking area. And also typically if a project is funded by a national body, this needs some academic, let's say, supervision as well, so that this money is really used correctly. So here we have also some activities as a university to monitor such projects.
Thank you. So I'm looking forward to seeing how this field evolves, how we come up with new technologies, but also a broader availability of some of the leading edge technologies that we have now. Thank you so much for joining us today, and we're going to continue with our seminar now. Now let's head to Trondheim, where my colleague Håkon Kvarme will give us a tour of the Frigg heat pump. Håkon?
Thank you, Fredrik, and welcome to our heat pump here at Felleskjøpet. The heat pump is actually installed in this room behind me. So come here and have a look. Outside this room we have installed the energy recovery unit that capture excess heat from moist air and transforming the water at about 25 degrees to this heat exchanger. So this heat exchanger is the first stage of the process. From this exchanger we are delivering to the bottom cycle. In this case we have a two-stage bottom cycle. First of all we have screw compressor followed by a piston compressor. After going through the two-stage compressing, we are delivering the output to this unit, which is a heat exchanger. And this heat exchanger is responsible for generating steam. And in this case, it's generating steam at about 85 degrees. The steam is then transferred to the top cycle. The top cycle is located in another room. So come with me and have a look. And here we have the top cycle. As mentioned before, we receive steam at about 85 degrees. The top cycle is responsible for compressing the steam. In this case, it's compressing the steam to about 2 bar or about 120 degrees. And the output on the steam is then transferred back to the production process here at Felleskjøpet. So we are actually catching energy from the waste heat, transforming it, and feeding it back to the production process. So that was a brief walkthrough of the setup here at Felleskjøpet, Skansen. Hopefully you get some more insights. And if you have questions, just ask me.
Håkon, that looks like an impressive technology integration. So can you tell us some more about the efficiency, the COP, and the capacity of the heat pump that you've shown us?
Yes, of course. This setup here at Felleskjøpet, we uses about 1.2 megawatt excess heat. And at the maximum peak, we produce about 2 tons of steam per hour. And regarding efficiency and the COP, it ranges from 3.1 to 3.4, depending on the operational conditions here in the factory. And also, this setup accommodates a lift of temperature from about 90 to 100 degrees.
Thank you, Håkon. I'm now joined in the studio by Vebjørn Nilsen, CTO at Felleskjøpet, and we're looking forward to hearing why Felleskjøpet has invested in steam-producing heat pumps.
Yeah, thank you. Great to be here. We are from Felleskjøpet, agriculture company, and we are now going to look into a feed plant producing compound feed. We are also producing food for pets, the biggest producer in Norway. And at Felleskjøpet in Trondheim, we have installed a huge heat pump to reduces the steam consumption. I will show you where we're using the steam. We have a lot of raw material, we are dosing them, we are making them through a hammer mill, roller mills, and we're mixing it together in batches, and we need to put in steam to have hygienic products. And all that steam, about 5% of the compound is steam we're putting in. More than 81 degrees, everything needs to be, and that amount of steam needs to be cooled out again. And today, and in the past, we were just taking the air from outside, all the heat was going out again, we were not using it to anything. And now I can show you the new situation. Yes, we are still using this raw material, the dosing and mixing of things. But now we have introduced the steam pump, and we're taking the heat from the cooling pipes. We're taking the heat into this heat pump. It's different steps with compressors. We have a screw compressor, we have piston compressor with ammonium, and we are using this huge heat transfer into these turbofans. And I can tell you, this one is much bigger than Heineken's. And but still we are using from this one steam into the pipe again and into the mixer and the hygienizing of the feed, and then we are making pellets into the cooler, and then we have the hot air, and the hot air is then going into this heat pump because we're taking the heat into the heat pump, and then this cycle is getting around and around, and we have this benefit from the energy. And now you can see the steam pump is with the different stages. It is a bit more than these compressors. It's also a bit more equipment you can see. And we are producing more than 2 tons of steam every hour with this steam pump. And we can see that the effect we are getting out is even better than we make through these calculations. We had to put in some factors to be really safe, and we can now see that we are producing more steam and we are using less energy, and we are recovering even more than we were dreaming of when we started this project. So vi are vent litt. Skal jeg bare måke på? Unnskyld meg at jeg stopper her nå. Yes, the traditional steam that we are using in a feed plant is that the steam boiling house is a lot more than 5 bars, and we are transporting the steam, reducing the pressure, we are using the steam into the feed. You can now see that we are using a low pressure heat pump. Everything is quite easy for us with this heat pump. We see that we have this technology that is in good function for us. And we have only this old boiler house is partly when we're starting up the process, Monday morning or Sunday evening, and then we are running with the heat pump afterwards. Thank you for your attention.
Thank you, Vebjørn, for the presentation. So what were your concerns during the planning and installation phase of this project?
The main concerns was that we made something could stop the plant, clogging some pipes, make water in wrong places, and the factory was not running properly.
Because in this case, the factory is operating, and we want to add a steam-producing heat pump, introduce it to the system without any disruption to the flow of production.
That's correct, and we need to run this plant 24/7 almost. Yeah.
So there really isn't much room for error or delays in the switchover.
No.
What were the ways that you worked around these constraints?
We had good plans and working together with smart persons and made plans that we could follow.
And you were also quite inventive because the Frigg heat pump had to be hoisted into the factory through the roof.
Yeah, through the roof. Yes, we made some places, and we also had to clean the place and made nice space for this heat pump.
And now it's been integrated into the factory. Have there been any issues so far?
No, we don't have had any big issues. I was, as I said, concerned that something could happen. It was okay.
So tell us a little bit about Felleskjøpet's motivation for switching to steam-producing heat pumps. What drove that change?
Felleskjøpet are using a lot of steam and energy to make a hygienic feed, as I told, and I've been there some years, and in the past we are putting a lot of steam into the products, and we are cooling it down, and this heat is was getting out of the roof. Now we are using less energy, and we have emissions lowered.
So let's say I have a factory and I'd like to introduce steam-producing heat pumps into that factory. What should I be aware of?
Yes, we have an old factory, and we are introducing a new combination of machines and all the interfaces in the new machine and also into our original plant. We have to be concerned and clean cuts between them.
So we might have to make sure all the interfaces are running perfectly before introducing the steam-producing heat pump?
Yes, and you have to just plan them and have good documentation.
Steam-producing heat pumps, they reduce emissions and they give us better control over energy use. Are there any other advantages that people should be aware of?
Yes, we can adjust the steam in a new way compared with this old-fashioned steam house and with the old valves. Now we have these special fans, and we can adjust it even more. I can control the overheating and several things. We're getting better quality in our products.
And what about installation sizes? Does it mean that we can build lighter and smaller?
Yes, we can build lighter and smaller, and we can make a kind of copy of what we have. We can make it a bit more simple. We know that technology is now in good function.
So what role do you think that steam-producing heat pumps will play at Felleskjøpet in the future?
I think we will look into more projects and the next factories to introduce more heat pumps, but not only Felleskjøpet shall do it. It is a lot of energy waste out there.
Thank you for taking time in your busy schedule to join us here today. Now we're going back to Michael.
Yes, thank you, Frederick. I would like to outline today also a little bit how Aneo Industry is basically operating and bringing this kind of heat pump technologies to our customers here. As we have now heard all the time before, industrial heating is around responsible for 1/3 of the global CO2 emissions. And this is actually true for most countries when we talk about their primary energy consumption, that around 1/3 of the energy is going to the industry, 1/3 is used for transportation and cars, and 1/3 is used for heating or cooling of houses. So heat pumps can really play a major role in decarbonization for the industry. And they are maybe one of the few technologies that actually make it possible to also reduce the OPEX of the industry, or the operational costs. So a typical customer for Aneo Industry has a waste heat source on site. This is typical for food, pulp and paper, but also chemical industry, and that we get this access to this waste heat. And the challenge of our typical customer is also that they want to substitute fossil fuel heating, by something renewable because they have ambitious sustainability objectives here. And we also see that there's an increased regulatory pressure on our customers, especially also in Norway, where we talk about to ban fossil fuels in the future for the industry. So there's a certain motivation and pressure to be an early mover also to take up this technology. In Aneo now, we are taking this customer and we are basically buying a heat pump and install it on the customer site and operate it for the customer. So this is a very comprehensive service portfolio for heat pump technology, and we make it hereby, which enables basically that the customer can get significant reductions of CO2 emissions without having capex costs upfront. And I also would outline that we are using a future-proof heat pump concept based on natural refrigerants, basically ammonia and water as refrigerant. And also Cordin was in this presentation. He outlined that ammonia and water is really one of the refrigerants, natural refrigerants, which had the highest acceptance by the market. So what do we do? As we saw, we basically have two heat pump technologies in our system. But in order to get this running and integrated into the factory, it's important that we also have a unit, what we call the energy recovery unit, which takes the waste heat from the factory and recovers it and brings it to the heat pump. So this is basically a heat exchanger. In the case here that we have presented, the heat exchanger is designed and operated with moist and dusty air. And so we have to cool this air down, and we recover then the waste heat in this heat exchanger and transport it to a water cycle. So this now the main challenge of the heat exchanger here is really not so much to recover the energy, but to handle real industrial conditions, especially the dust I'm thinking about here. However, once the heat is then transferred to the bottom cycle technology, the bottom cycle technology is producing steam at around 80 to 90 degrees out of this heat. And the two main functions of the bottle cycle are basically to, on the one hand, cover and compensate for variations in the waste heat temperature and to produce steam at a very constant and defined point between 80 and 90 degrees. So then from this point where we have the steam, we are then starting to generate, to compress the steam up by the series of compressors. We can deliver steam up to 5 bars, so 150 degrees Celsius. However, what we do in the factories, we do basically in-depth integration. That means if the process only requires 1 bar steam or 2 bar steam at 120 degrees, we only supply this lowest possible pressure and temperature to the process in order to get the best COP out of it. So the challenges for the process industry, in most cases we are involved in, is actually that they, when they get in contact with us, they want really to need, they require basically process steam and not hot water. A lot of heat pump technology is designed to deliver hot water, but it's more universal usable if this heat pump is actually supplying steam. And I also must outline that the excess heat is normally not clean or clear of any particles or so on. So the excess heat recovery unit might be is sometimes a little bit under-communicated how difficult it is to get the right technology there on site. And by doing this setup here, recovering excess heat, especially from when it's sensible as well as latent, we see that the real energy recovery temperatures for the industry are normally below 40 degrees. There I'm quite frequently confronted with some cases where I say, yeah, we have 70, 80 degrees waste heat. But when we look at the case in detail, we see, yeah, you have maybe 1 kilowatt at 70 degrees, then you start to cool down your waste heat stream. And in order to get out 1 or 2 megawatt, we need to cool it down to 40 or 30 degrees. So if we want to get out a significant amount of waste heat, we need to cool it down below 40 degrees in most cases. And that means also we have a high temperature lift to cover, so we need an efficient heat pump system, which requires this in-depth integration, as I have outlined before. And last but not least, operation and maintenance of heat pump technology is more complex compared to gas boilers or electric boilers. So this is also some of the challenges that the industry is facing, because if you are producing feed pellets, food, pulp and paper or whatever, you don't want to necessarily be an expert on heat pump operation. You want to be an expert on how to operate your process. So that's also the part that's at Aneo Industry is covering. We basically are responsible for the right operation of the heat pump. If I put the technology setup together and bring it into this operational map here for our heat pump system, we can safely say that our heat pump is typically designed to deliver temperature lift of at 80-90 degrees up to 110-120 degrees. And we do this by achieving an efficiency, a Carnot efficiency is around 60%. In this example here, temperature lift of 100 Kelvin, and we got the COP of 3.0, and that's very important for the business case to have a high COP to give a good energy price to the customer. And also important is that our system is able to cover excess heat source temperatures as low as 20 or 30 degrees and still are able to produce steam above 100 degrees out of this. That also basically means that we are very generally usable and the customer has a much better application potential if we supply with this operational map. Yes, if I put now all this information that I was presenting and the performance of the heat pump and do a cost analysis here in the form of a total cost of ownership, I'm able to compare heat pumps to electric boiler, gas boilers, but also biofuel and hydrogen. What we can clearly see that the heat pump is a quite expensive technology. That's why the blue part comes basically in. So heat pumps are more expensive, and in this case we have written down the investment over a 10-year period, which means the cost of ownership in the first 10 years are higher because of the high investment basically. What we also see is that since we are reusing waste heat, the amount of electricity, basically the orange part we put into the heat pump, is much lower compared to the other systems here. And that also means if, for example, the energy prices go, or the electricity prices go up by 200% in a year for whatever reasons, we are less dependent on future energy price developments. And last but not least, in this total cost of ownership, we also see that the service costs are higher for heat pumps. But still, if you put these three cost elements, investment, primary energy use, as well as service and operational costs together, the heat pump is more competitive when it comes to pricing than most of the other technologies. Of course, for this graph, I must be honest, I have chosen an example which is very beneficial for heat pumps. A large system, around 5 megawatt, operating around 7,000 hours per year. And I used the energy price of, I think, 2 or 3 days ago. Since the energy price is always changing, this graph is basically also changing all the time, but it gives a very general impression how heat pump can be competitive in the general, compared to other technologies available in the market. So, in summary, from our side, from our Aneo side, we have our business model is basically bring heat pumps to the customers. We are also covering the technical risk. We are only getting paid when the heat pump is delivering energy. We are basically paid for the performance as well as that we have a high operational time on the system here. If the heat pump system wouldn't work, but it will work, that risk is basically on us. So that also means that our customers now can focus basically on their main business and don't need to become a heat pump expert today to get this technology already today. And by that we also are able to give a competitive price compared to fossil fuels, gas, but also future electricity prices and so on. So thanks for that. I hope this was clear. If you have any questions, please follow it up later, or email or something. And then now back to you basically, Frederick.
Thank you, Michael, for the run-through. So if you want to know more about Aneo Industries high-temperature heat pumps, reach out to Michael. But also, if you're going to Chilventa, which takes place in Nuremberg, Germany on October 8, 9, and 10, you should come and see us there. That's all for today. We look forward to speaking with you again soon. Have a good one.